Hi, in the vigorous day. I am Mark Robert P. Condestable, a grade 11 STEM student of Section del Mundo from Parañaque National High School, Maine. For today's erudition, I will be explaining as well as presenting certain topics and examples about the rules of differentiation and the chain rule of differentiation. As we begin our discussion, let us keep in mind our denotations for the given topics. Let us consider having f of x, d over dx, y prime, and dy over dx. So, what are the rules of differentiation? These are actually the rules for computing the derivative of function in calculus. First, we have the constant rule. What do you think is this? If f of x is equal to c, where c is a constant, then f prime of x is equal to 0, or the derivative of a constant is equal to 0. In simple terms, if we have a constant and we try to solve for its derivative, the answer will always be 0. Let us have an example. Let f of x be equal to 10. Therefore, f prime of x is equal to 0. This denotation can also be written as y equals 10, therefore dy over dx is equal to 0. Note that same goes with other constants. Second rule, the power rule. In this rule, if f of x is equal to x raised to n, then f prime of x is equal to nx raised to n minus 1. Example, f of x is equal to x raised to 5. What are we going to do? As we spoke earlier, we will be placing the value of the exponent beside x, as well as subtract the given exponent to 1. We write it as f prime of x equals 5x raised to 5 minus 1. And as we simplify, our answer will have an answer of 5x raised to 4. Third rule, the constant multiple rule, wherein we apply the constant rule as well as the power rule. So how do we exactly do this? If f of x equals k times h of x, where k is a constant, then f prime of x is equal to k times h prime of x. So, we get the derivative of h before proceeding on multiplying to its constant. So how do we do that? For example, f of x is equal to 5x raised to 3 over 4. First, we separate 5 and then get the derivative of 3 over 4 by using the power rule. Then it becomes f prime of x equal to 5 times 3 over 4x raised to 3 over 4 minus 1. In this manner, we can now multiply 5 times 3 over 4 as well as subtract 3 over 4 by 1. And have our answer as 15 over 4x raised to negative 1 over 4, or rewrite it as 15 over 4x raised to 1/4. Fourth rule, the derivative of a sum or a difference. In this rule, if f of x is equal to gx plus or minus h of x, then f prime of x equals to g prime of x plus or minus h prime of x. So how do we do this? Let us have an example. Let f of x be equal to 3x squared minus 7x. In this given example, our operation is subtraction, wherein we get the difference of the function. Note that 3x squared is our gx, while negative 7x is our h of x. Let us get the derivative of 3x squared using the power rule, and we get 6x. And then, the derivative of h of x, which is negative 7. So at this point of time, we now distribute our answers, which will become f prime of x equals 6x minus 7. See? It's easy. Now, rule number 5. The product rule. How do we do this? Let's say, derivative of the quantity of f of x times g of x equals f of x times g prime of x plus gx f prime of x. In simple terms, cross multiplication. Or first times the derivative of second plus second times the derivative of first. Example, y equals 3x squared minus 4 times x squared minus 3x. So at this moment, we get the first factor, which is f of x equals 3x squared minus 4, and then get its derivative, which will become 6x. Next, the second factor, which is equal to x squared minus 3x. Again, the derivative wherein we get 2x minus 3. Now we just need to follow the given formula. And as we distribute, we will have y prime equals 3x squared minus 4 times 2x minus 3 plus x squared minus 3x times 6x. As we proceed on multiplying, we get 6x cubed minus 9x squared minus 8x plus 12 plus 6x cubed minus 18x squared. Now we combine the like terms, and we get the answer of 12x cubed minus 27x squared minus 8x plus 12. Remember that we always use the operation of addition in the product rule. And last but not the least, the quotient rule. Rule number 6. For this rule, let u and v be functions of x. For our f of x and g of x over h of x, then the derivative of f of x is h of x times g prime of x minus g of x times h prime of x all over h of x squared. Or low-d high minus high-d low all over low-low. Do you remember that we used addition in the product rule? Note that here in the quotient rule, we use subtraction. Example, y equals 5 all over 3x plus 4. We get the first factor, which is g over x equals 5 and its derivative, that is 0. Next, the second factor, which is h of x equals 3x plus 4 with a derivative of 3. Now, we distribute the given formula, and we will have f of x equals 3x plus 4 times 0 minus 5 times 3 all over 3x plus 4 squared. We simplify and we get negative 5 times 3 over 3x plus 4 squared, or negative 15 over 3x plus 4 squared. And that's all for the rules of differentiation. Now, let us continue on our next topic, the chain rule of differentiation. The chain rule is a formula in calculus that represents the derivative of the combination of two differentiable functions, f and g, in terms of f and g's derivatives. If u equals g of x and y equals the quantity of g of x, then dy over dx equals dy over du times du over dx. Note that aside from expanding as well as getting our product rule, the chain rule can also be used, mainly because the chain rule is genuinely useful, most especially when our exponent is quite large. Differentiate y equals 4x plus 3 squared. Based on the given example, we can actually solve this using the product rule as well as expand it and give its derivatives. But for this time, we are going to be using the chain rule. We multiply the exponent to 4x plus 3 and then subtract the exponent by 1. That will be y prime equals 2 times 4x plus 3 squared minus 1 d over dx 4x plus 3. And we will be getting the derivative of 4x plus 3. Our answer will become y prime equals 2 times 4x plus 3. The derivative of 4x plus 3 is 4. So, the derivative of the quantity of 4x plus 3 squared is 8 times the quantity of 4x plus 3, or distribute our function and it will become 52x plus 24. So guys, have you learned anything about the rules of differentiation as well as our chain rule? If you did, good job! Again, I am Mark Robert P. Conestable, your math tutor of the day. Thank you!